Hello APCS students, this is Mr. Ferrante and here's a tutorial on how to implement custom shapes and filling them, which is not part of the regular GP draw, but you can make it. So someone had asked for a strategy for flood filling polygons, well actually just flood fill in general, and here's what we mean by that. I have paint open, and if I select yellow and click the paint bucket tool, then you can flood fill a region, and the filling stops at the boundaries of the shape. So let's fill these yellow, maybe select blue, and then flood fill the background with blue, and that looks awesome. Now in GP Draw, you can't really do this. We will study official flood filling late first semester or maybe early second semester, but for now, GP Draw can't actually flood fill easily. It can, but to do that, you have to go way into the depths of Sketchpad, which we're not going to do. So instead of flood filling, which requires you to ask the question, is there a pixel at this location? But there's no method inside of GP Draw to ask if there's a pixel at a certain location and what its color is. That's what you would need to do actual flood fill. So instead, what we're going to do is we're going to teach you how to draw polygons that can be filled. And so we just went over what's flood fill, and now here's our polygon demo. So I've already done this to make sure my strategy actually works, and it does. So here's a polygon test. If I just run this, I get a polygon. It's four-sided. I added labels for the vertices. You can get rid of those, but the point is, by default, GP Draw can't draw weird shapes, but if you implement my strategy, you can draw any n-sided figure no matter how weird it is. So that's the idea. And then you can flood fill like a roof, that's kind of an awkward shape, and so on. So in this video, I'm going to explain one possible strategy for filling a polygon. And one clarification, this strategy works only for convex polygons. So if you have a dot here, maybe here and here, this would work fine. Actually, let's do a five-sided shape. There's a five-sided shape, and if I connect these, this polygon is convex because it has no indentations. That's what the algorithm will do. If I back up, and let's say you take this point and move it inside, depending on the order these are in, let's say this is vertex 1, that's 2, this is 3, that's 4, and 5. The vertices have to be in some sort of organized order, otherwise you wouldn't know how to connect them. So if you do this, this is a concave polygon because it has an indentation. If you used our algorithm to color this, it'll end up filling in this section as well. So, but it's not a problem because technically you could simply break up this shape into two polygons, a triangle and a quadrilateral, and then you're good. So in reality, you can do concave ones if you make it two or more polygons. All right, so assumptions about our algorithm that we're going to develop. It has to be for convex polygons, no indentations. And number two, the vertices have to be specified in order. You can't just say something like vertex 1, I don't know, vertex 2, vertex 3, vertex 4 down here. Because then you get this, 1, 2, 3, 4. Well, that's a weird shape. So when you specify your vertices, they have to be in some sort of like clockwise order around the shape. So those are the assumptions we're going to go on for our algorithm to actually work. All right, next up. This is only one possible strategy. There are many strategies. I just literally, when the question was asked, I went home that night and I just sat down on the couch and I thought for about probably 15, 20 minutes. And in my mind, I came up with a strategy I thought would work. And then I detailed it on paper, did some pseudocode. Then I tried it and it totally works. And you just saw me using it. So here is the strategy. Let's say you have a five-sided shape. That's vertex 1, vertex 2. Let's say 3 is way down there. And then we'll put 4 right here. And then vertex 5 is way off to the side. So for sure, this is kind of a funny shape. It goes like this. 1, 2, 3, 4, 5, and then back to here. So that's convex. We're good there. It's also specified in order for the vertices. And how we're going to shade this is just like in 3D graphics. You may not know this, but especially back in the like Nintendo 64 days, all the characters on screen were actually broken up into a bunch of triangle meshes where, you know, Mario's face, this is Mario, blah, blah, blah. This is like 3D Mario. Well, if you looked in closely, you would see that there's actually a bunch of triangles, like tiny ones, defining the surface of everything. So what we're going to do is the exact same technique. We're going to break up our polygon into triangles and simply shade triangles. So to do that, you take your first vertex and you connect it to 1 and 3, and you build this first triangle, and then you shade it. There it is, shaded. Then you build the next triangle. Still stick with vertex 1 as the anchor point, and now choose vertex 3 and 4, and that gives you this triangle. And then you go and you shade it. Then you keep going until you have done your final set of vertices, in our case 1, 4, 5, and you shade that. This works for any number of vertices, so you can shade any complex or convex polygon, even if it has 100 vertices. You simply break it up with an anchor point into a bunch of triangles. So that is the strategy, which means all we've got to do is figure out how to draw a general triangle and shade that puppy. If we can do that, we are good to go. So let's focus on triangles. So here's one possible way to shade a triangle, and again, I just made this up. There are many ways to shade a triangle. This is one I sat down and just thought, what's kind of an easy way to do this? And I thought this was a pretty easy way, so here we go. All right, let's consider a triangle with vertex 1 here. Maybe vertex 2 is here, and vertex 3 is way off to the side up here. So there's vertex 3. So here's our triangle, something like that. So what you do is find the location of the centroid. The centroid is simply the average point of all points. So I think it'd be about here. But here's how to find the centroid. Either Google it yourself, how to find the centroid, or just realize it's just the average of the location. So the x-coordinate, let me make blue, the x-coordinate of this centroid is the average of all 3 x-coordinates. And its y-coordinate is just the average of the 3 y-coordinates. And that gives you the centroid of the triangle. And since we're doing, yeah, it's always going to be, I think, in the interior of the triangle. I haven't tested to see if you have like a really just like wacky triangle, if the centroid could possibly be outside. I think it's not. But I haven't thought about verifying that. So let's just hope that it's actually always inside. Otherwise, that's going to mess up my algorithm. All right. I'm going to pause this video and come back because someone's calling me. All right, thanks. I'm back. In between a second ago and now, I had to take a call. That was important. So thanks so much. Alrighty, so we said to draw a triangle, you take the vertices, let's just say they're here. That'll work, good enough. And then you find the centroid, which is kind of like the average weight of the triangle. And then the algorithm is you basically take your original vertices, which are here, and what you do is you simply connect those. So you would draw a line from vertex 1 to vertex 2 to vertex 3 and then back to vertex 1 to get the outline. And then you simply move these vertices in towards the centroid. So this point number 1 or vertex number 1 is going to move slowly into this centroid point. Also, vertex number 2 is going to move very slowly, which my dots are not slow, but towards the centroid. And vertex 3 is going to do the same thing. Let me get this written in here. So the idea is as follows. You draw the original outline, and then you simply go back, and you move each point in by basically 1 pixel. And you redraw the vertices. In this case, vertex 1 comes in, and you simply draw the next outline, which is going to be slightly in here. But if you do it properly, which I'm not because I'm hand drawing it, if you do it properly, there will be no space between these 2 outlines, and you're going to get basically a slightly thicker triangle. And then again, you move your vertex inward and you draw the next outline. And you continue this until finally the vertices all meet in the center. And you're basically drawing a bunch of triangle outlines going inward. And the outlines are going to be so smashed together and so close that the triangle will appear solid. And so that is the strategy. And then next, let me pause again. I have another call. I'll come back in a second. All right, I'm back. Thanks again for your patience. So that is the strategy. And from there, many of you that had intro can just implement that strategy. It'll still take some problem solving to do it, but you have the skills, I think. Here's some things that came up when I did it, just to give you some heads ups. One question is, how do you move the vertices inward? So let me go ahead and draw our triangle. There's a good one actually. Again, vertex 1, vertex 2, vertex 3. Doesn't really matter how you label them because they're always going to be in a clockwise order. But how do you actually take a point and move it inward? Well, here's one possibility. The first question is, how did you represent your vertices? Did you represent them as their own x's and y's? Like, for example, this is x1 and y1 was your variable. Because if that's the case, you just need to modify x1 and y1 variables to move it over by a little bit. Same thing with 2 and 3. This might be like x2 as the variable and y2, and then that would be the 3's. A second choice is you could use a point class, and you can make your own point class. I guess I'll do that in a future slide here, but basically this here will work, or you could use point objects if you want to go into that. But basically modify the value of variables, that's how you move the points over. So next question is, by how much do you move the points? This matters actually a lot. If you don't move them by enough, or you move them too much or too little, or whatever, actually by too much, you're going to get spaces and white space inside your triangles. It won't be solidly filled. So here's how to do that. Let's say the centroid in this case would probably be about here. And then look at the connection between your vertices and the centroid, and look at the line lengths. If you want to get a solidly filled triangle, then let's say that this longest line here is 200 units or pixels long. Then what that means is, at a minimum, you need to step and loop 200 times, starting here and then ending here, because this vertex needs to slide by 1 pixel per triangle. And in this case, this is telling you you need 200 triangles so that there's no white space in between. So what I would do to figure out how much to move by is, you'll have to find the distance from the centroid to each vertex, then figure out which one's the longest distance, and that's going to be how many triangles you need drawn, and that'll kind of be your loop boundary. Then how much to move the points by? Well, you'll have a loop that goes from 0 to whatever length, in my case 200, and you'll have a starting location of vertex 1, and then plus the percentage of the way you are along this line. So at first, it'd be the original location plus basically 0% of 200, which keeps you there. At the next iteration, you'd be only a little bit over, because you would have vertex 1 starting point plus, whatever percentage of this is, which would be, 1 out of 200. That would be your percentage of the 200, and so on and so forth. So your loop will slide this point farther and farther, and you simply apply that separately to the x and to the y, and together they will slide along the proper point. So that's what I suggest. It's basically a loop and a percentage of sliding along this 200. And then finally, how do you represent points in Java? Like I said, you could say there's just x1 and y1 variables, and then x2, y2, and so on. That's just the easiest way. But here are 2 other considerations. One, you can make your own point class. That's very convenient. So let's go here and do this. I'm going to say new class. I'll call this point. And let's define our point class. So Let's just wipe out this whole thing. Public class point. All right, so a point should keep track of an x and a y coordinate. So clearly we need two attributes. I'll say double to handle decimal precision. Double x, double y, and that's sufficient. For our constructor, public point will accept an x and a y, so double new x, double new y, and we'll initialize our attributes to the given values. And now we need some setter and getter methods so that if we create a point, that's great, but you have to be able to access the information and also change it. So we're going to make a, let's see, a getter method. That's misspelled, but that's fine. Here we go. So public double and then get x. This should return the x value. And then let's call this getter methods because there's a bunch of them here. We're also going to have a get y coordinate method to retrieve the y value. That'll return that. So now you can create a point object and then ask it what its x and y coordinate is separately. Also, we probably need a set x and set y. So let's add one of those. These are setter methods. So I'll label them as setter methods, and then public void set x, and then simply update the attribute that the x attribute now equals the new value passed in, and you would do the same thing for y. So then you have a utility class that can store locations in the form of an x and y pair. You can grab the individual locations and you can modify them. So I'm going to compile this even though we're missing y. It's all good. So compile this. But the way you would use it is inside another class, like let's do a little driver here. Actually, let's go back to, hey, I'll make a new driver. New class. I'll just call this driver. It's a pretty bad name, but too bad. All right, so to create a point inside the main method, let's just say this is the main method. And I'm just summarizing. You would say point P, maybe P1 equals new point, then pass in, I don't know, 50, 30, whatever you would like. And then you could say P1.getX and P1.getY, and maybe store those somewhere. So double X equals getX, and do the same thing for Y. Then you would be able to pull out the values and use them. So anyway, the point is that you could create your own point class and then you have your own methods to get and retrieve and set information. So that is one option. Then another option is to use the built-in classes for Java. They're harder to use, but they're not too hard to use. And that would be the point2D double class. So search up point2D Java API. And let me shrink the page so you can see it better. Here it is. So there's already a point2D class, and to use it, this class is it's abstract, which means it's just a template that you can't actually build objects from. You have to build an object from one of its kids. So point2D.double is a subclass which can be used and compiled. So when you actually go to use this, use point2D.double, and it has lots of useful methods, just like we had. Well, okay, a few. Get x, get y, and so on. But the thing is, it inherits these methods. You can find the distance from one point to another. So you have these methods to use, plus you have all of these methods to also use, which will calculate distance for you, for example. So that's why I would use perhaps this. And again, to use it, let me show you an example. I'm just going to throw this in randomly. You would have to first import the class. So to do this, you would import this right here. You can do it on your own. And to use it, you'd say point2D.double, whatever, P1 equals new point2D.double. And then you would pass in the information needed in the constructor, which is not nothing. It's actually in its parent, point, you would pass in an x and a y coordinate. So that's what we'll do. So 59, 30. So that's how you would create a point, and then to use it, you would simply say p1 dot whatever method name you wanted to use. So that's another option for storing and retrieving points. All right, let's check in with the PowerPoint to make sure we're on track and to see where we are. Those questions have been all answered. And back to polygons. All right, you have many choices on how to implement this. It's up to you. If you want, you could just hard code the locations of a particular polygon, and that'll save you a lot of work. So if you want a particular polygon in your program, it's okay to just hard code x1, y1, x2, y2, and so on. Then you would get like a certain roof on your house that's a certain shape, and it's the same every time, but at least it's easy to implement. If you want to get more fancy, you could create a list and store your points in a list. And to do that, you have a few different ways. To store your polygon points in a list, you could create your own arrays to store the x's and y's separately. To do that, it'd be something like this. Okay, I'm just typing this in randomly here. I would say double because you need your vertices to have decimal precision. So double, this is an array. So I assume last year you did arrays in intro Java. If you haven't, this is maybe too much, but here we go. Double X list, and you could then just hard code, a list of numbers. I'll leave this blank for now. Then do the same thing for your Y list, and together, let's say you want the first point at 50, 30. There it is. You just separate them, one in the X list, one in the Y list. Next one, -10, 50. So you make a list of points, and they're paired up this way. And so that's one option. A second option is you could use an array list, which is more advanced. We're going to do this later this year, but if you want to research it, you could use an array list of point objects, which is the one that you created, or an array list of point 2D objects, dot doubles. So these will all work. It's up to you how to store the points, but you can always hard code if you're being driven crazy by how to make lists. Because in reality, all this stuff is later this year, and it's really kind of too early to be expecting you to do this. And then finally, if you did make a list, here's what you do. To make your polygon, you simply iterate through your list and create and fill triangles. So if you have this six-sided shape, 1, 2, 3, 4, 5, 6, remember, you'll define these in order. So you'll put these vertices into your list in the order of clockwise or counterclockwise. You'll pick I'm going to call it an anchor, and you'll simply create the first triangle between these 3 points. You'll shade it, and then you'll iterate through the list and using a loop, and then you'll choose the next set of 3 points, which happens to be these 3, and you'll do here to here to here. We'll create that triangle and fill it, then go on to the next one, right there, triangle, fill it, next one, triangle, fill, and you'll end up with a clean loop that accesses vertices from a list, and it'll be kind of a cleaner way to do this. Otherwise, you're hard coding everything, and that's still fine, but it's not as efficient or robust. So those are my strategies for how to implement a generalized polygon. If you want to do a concave polygon like this one here, here's a concave polygon because it has an indentation. Then all you need to do is break this up into 2 polygons. Here's a triangle plus a quadrilateral, and then you're good. So you could make a new class that is basically a collection of polygons that are concave or convex. Let me go back to my polygon test. So here's my polygon. Again, it's 4-sided, but I store these in a list. So if I add another point to my list, which I'm going to do right now, then you can see that I'm going to get a 5-sided shape. So let me go ahead and pause the video and do that. All right, so I added an extra polygon vertex. I'm going to compile this, I'm going to run it, and now you can see that I've added an extra point, and I have a 5-sided shape. So there it is. I would remove my little vertices. That was just for debugging and seeing where things are. The red is my anchor point, but we have a nicely filled polygon. And perhaps the last tip I should add really to this section here, um, well, actually to this section is you should set the drawing tool's width to 2. So make sure you set your drawing tool width to 2. That way it'll fill in the shape much better. So there's that. And you might have to increase the number of iterations. Instead of just drawing a certain number of triangles, draw twice as many. And so together you'll get a nicely filled polygon and you'll be on your way. So thanks for listening. Have a great day. Bye.